right, so we continue with our mock paper. Okay, let me project the slides. All right. If I'm not clear, do let me know. All right, if I'm not clear. Okay, we'll do this later. All right, there's this link that I will need you to let me know which topics you need help with so that I can offer you more help as you prepare for your Set 2 end of the year streaming examination. Okay, so for Sharon who is new to my lesson, feel free to type into the chat whatever you do not understand. All right, so I'll be asking a lot of questions through the chat. So if you're not so sure, just type not sure. All right, IDK. IDK means I don't know. All right, but you also can make a wild guess. Okay, you can type your answer and put a question mark if you're not sure. All right, it's okay to give the it's okay if you give me wrong answer, don't worry. All right, so I'm very happy to help you. So I need responses. All right, thank you for telling me, Chen Xing. All right, so at least I know Chen Xing say he needs more help for the chemistry part. All right, so let's continue then. Okay, this is a promotion. You'll go and read it on your own. All right, so let's start. Okay, so it's already 7:38. Now, which statement best describes the potential difference across an object? All right, for this part, right, looking at, let me see, the file. Okay, most of you got this right. Okay, only one of you got this wrong. All right, so I'm going to type what is needed for you. Okay, now when you have ratio means, just a minute. All right, of voltage to current. Okay, so you have a voltage divided by current. Okay, so this is the current. Okay, so this is the voltage. All right, and it gives you the resistance. Okay, so R stands for resistance. So you have to know resistance is equals to voltage divided by R, divided by current. All right, if this helps you, this is the triangle. All right, so you can write video is real. All right, the memory aid video is real. Okay, so if you want to find resistance, you circle resistance, use your finger to cover resistance, then the answer will be V over I. So if you look at my highlighter, if you want to find resistance, take a finger, cover up resistance, then it will be, sorry, I write the other way around. So I always write on top. Video is real, is starting from the top. All right. So video is real. It has to start from the top. So if I want to find resistance, I will then take voltage divided by current. All right, that will help me find resistance. Okay. So it's a ratio. Ratio means something divided by something. So it's voltage divided by current. Okay. Then rate of flow. All right, rate means per unit time, per 1 second. All right, per 1 second. Every 1 second, how many charges are flowing through? That is current. Right, so this is the definition of current. All right, current means in 1 second, how many charges flow in the wire? All right, in 1 second, how many charges are flowing inside the wire? That is current. Okay, so there's no such thing called ratio of current to voltage. That's wrong. That's nonsense. All right, then this one will be potential difference. Okay, so potential difference, another word for it is actually, anyone knows what is another word for it? Anyone? It's the voltage. Okay, so potential difference is the same as voltage. So it means how much energy is needed to move 1 unit of charge. All right, now 1 unit doesn't mean 1 charge. Okay, 1 unit is a very, 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 very big number of charge. All right, from one point of the wire to another point of the wire. Okay, or from one point of the circuit to another point of the circuit. That is potential difference. So the answer is A. All right, is everybody clear? Any questions so far? Okay, now I just put on the one slide what are the things you need to know for Set 1 and Set 2. Some schools will expose you earlier, some schools will not. All right, but I'll just put everything in one slide. So if you want current, it's talking about rate. Rate means in 1 second. All right, rate means in 1 second. How many charges are flowing through? That is current. Now potential difference, short form PD. or the same as voltage. These two are the same, got different names only. The voltage across a component, like for example, a voltage across a light bulb or a voltage across a battery, is how much work is done or how much energy is needed to drive, like to force or to push 1 unit of charge through the component. Now, notice that we all use the word charge. We never use electron in this case. Use the word charge for your definition. All right, do not use electron, use the word charge. So if you want to drive 1 unit of charge, 1 unit of charge is a very huge number of charge. It's a very, very big number of charges. All right, you want to push it through, for example, push it through the wire. All right, how much energy is needed? That is the potential difference. All right, so for example, if you want to know the potential difference across the battery, it means how much energy is needed to drive 1 unit of charge across, okay, from one point to another point. All right, resistance is a ratio. Ratio means something divided by something. So it's a voltage divided by current. Power is, there's a typo here, work done or energy transferred in 1 second. So here, notice that in 1 second, all right, how much energy is needed? Okay, how much energy is transferred in 1 second? That is power. So all these are the definition related to the electric circuits. Please familiarize yourself with these 4. All right. Okay, so just some to let you know, whenever we talk about 1 unit of charge, okay, in set 3, set 4, you're going to learn what is that unit we are talking about. The unit is actually coulomb. All right, coulomb you'll learn in set 3 and set 4. So 1 unit of charge doesn't mean 1 charge. It doesn't mean 1 electron. It actually means this huge number of electrons, which is 6, 2, 4, and then many zeros. All right, 16 zeros. Okay, electrons. So many electrons. That's what I'm saying here. There are so many electrons. And if you want to drive so many electrons, all right, from one point of the circuit to another point of circuit, how much energy is needed, all right, if you see the potential and difference, how much work is done or how much energy is needed to drive that so many electrons through the light bulb, that is potential difference. Now, another way to understand potential difference is how many joules of energy is being converted, all right, for each unit of charge, okay, for each unit of charge. All right, so coulomb here means unit. So for example, if you have 6 volts battery, all right, or in this case, 6 volts light bulb. Now, this lamp means the light bulb. I can change it to bulb if it makes it clearer for everyone. Okay, so if you have 6 volts light bulb, it means there's 6 joules of energy converted from electrical energy into other forms of energy for each unit of charge passing through the light bulb. So for 1 unit of charge, which is many, many, many electrons passing through the light bulb, 6 joules of electrical energy is converted to other forms of energy. All right. So if you have 12 volts light bulb, that means you have 12 joules of energy. All right, 12 joules of electrical energy converted to other forms of energy. So 12 volts light bulb will obviously be brighter than a 6 volts light bulb. All right, so this is just another understanding of what is the meaning of potential difference. But I think it's good to remember all these 4 definitions, all right, for electricity topic. Okay, let's move on. Now here is, you are talking about, you have a 100-meter distance and you're given the time. All right, so this person ran 100 meter and it's 9. For this question, a lot of you got this wrong. So what is the speed in kilometer per hour? All right, so over here, right, first is telling you, I want to find out how many kilometer in 1 hour. When you write per hour, actually, you see, per how many kilometer per hour, actually, there's a missing number here, 1. It means 1 hour. All right. So in 1 hour, so what you do is 9.58 seconds, you run 100 meters. All right. Then you ask yourself, in 1 hour, all right, how far can I run? Okay, now 1 hour is equal to 3600 seconds. I need to convert it to second. All right, so this is 1 hour. So then you use the bottom number, divide by the top number, times the right-hand side. Do you all follow so far? All right, so I use the bottom number, divide by the top number, times the other side. Okay, So given the question, it took 9.58 seconds to run a distance of 100 meters. So my question is in 1 hour, all right, in 1 hour's time, how far can I run? So in 1 hour, there's 3,600 seconds. Right? 1 hour got 60 minutes. Each minute is 60 seconds. So 60 times 60 is 3,600 seconds. So use the bottom number, divide by the top number times the other side, but make sure you use the same unit, meter. All right. Can you help me press your calculator and tell me what you have? Then okay, do you get this? Meters. All right. Now the question is, I need to change it to kilometer. So to change it to kilometer, right, you divide by 3 zeros, right? Decimal point go to the left by 3 places. You'll be 37.5782881 kilometer. So that will be approximately 37.6 kilometer. Right? So this means that if you look at what I'm highlighting, in 1 hour, I can run a distance of 37.6 kilometer. Therefore, this is the answer. All right, so this is the speed, 37.6 kilometer per hour. All right, so per hour means per 1 hour. All right, any questions so far? Right, so several of you actually got this question wrong. Okay, so I think what you need to know is whatever the question wants, the question is asking for this. So it means they're asking you how many kilometer, all right, in 1 hour. Per hour means 1 hour. Okay. Right, so then you just do your mathematics, all right? In 1 hour, how far can you run? Then here is seconds. So therefore, hour must change to second. Must make sure it's same unit. Second, meter. Before you do bottom number, divide by top number times the other side. All right, so meter, now you just change meter to kilometer. So to change meter to kilometer is actually divide by 1,000. All right, because 1 kilometer equals to 1,000 meter. Okay, any questions so far? Okay, now which effect cannot be caused by a force? Right, this is quite simple. Most of you got this right. All right, so force can change the direction of object. You know, when you push a car, the car can change from going straight and go left, right? If you apply a force on a piece of plasticine, the plasticine's shape will change. All right, if a car is moving, you apply a force, you can stop the moving car. So you can't change the mass. Mass will remain the same. All right, mass of the object will remain the same. Okay, question 4. In which option you do most work? Now, for this question, right, you need to know this equation. Now, work done equals to force times distance, which I'm going to write here. Okay, work done equals to, I want to find work done. Then I use one finger and cover up W. Then I have F and D next to each other. Next to each other means times. So it's force times distance. All right, so you apply this formula. However, you have to make sure that the force is the unit of Newton. Distance is the unit of small letter meter. Work done will be joules. All right, work done is the same as the unit for energy. All right, so in other words, maybe I'll write it here for you. Work done, the unit is joules. However, energy unit is also joules. Just take note of that. Okay, capital J, joules. So joules is the SI unit for work done as well as the SI unit for energy. It's quite easy to remember. You need energy to get work done, right? I'll give you a piece of homework. You need to apply energy. You need a lot of energy to complete a piece of homework, right? Okay, so once you know work done equals to force times distance, I have a memory aid here. You always start from the top. Just now I made a mistake, right? In the earlier part of the lesson, I forgot I write this way. So I always, for my memory aid, please start from the top. All right, so word for donkey. The donkey, when I traveled to Greece many years ago, there was a very quite a slope